Hey everybody, you already know who it is. It's Mr. D coming at you again with some more remote learning. Today's going to be good stuff. We're going to talk about pressure systems, and we're really going to focus on high and low pressure systems today and what those mean for weather. And we're going to kind of continue this look at some of these symbols used by weathermen, and you'll never watch a newscast the same way. You'll start to recognize some of these symbols on the weather map as these guys are talking, and you'll be like, hey, Mr. D taught me that. It'll be great stuff. Just trust me. So hopefully at this point you've got the note sheet opened up and it's in Notability ready to go. Remember, you can follow along with my video here and pause and fill in your notes. Those notes will be helpful on future assignments and assessments. So let's jump right in. Let's talk about air pressure. When we get done with this, we're going to work on today's assignment together. So again, just got to follow along with me today, and you'll have all your work done in no time. So let's do this. Let's talk about air pressure. You guys, hopefully at this point, have already seen me crush a can using only the air pressure in the room, right? We said air pressure at sea level is on average about 15 pounds per square inch, but it can be higher and it can be lower. So let's write this. The atmosphere is like an ocean. I love this analogy. We essentially live at the bottom of an ocean of air. So let's think of it this way. If that's the Earth, right? Here's the Earth, and here's our atmosphere, and we live down here at the very bottom of that ocean of air above the Earth. So we're experiencing a decent amount of pressure from all that air above our heads weighing down on us. It's squeezing us at roughly 15 pounds per square inch. But here's the thing. We like to draw our atmosphere like that and think of it as this nice, round sphere of air that envelops the Earth. We call it Earth's Snuggie, right? It's keeping us warm. But in reality, that's really not the case. If it's like an ocean, the ocean isn't always calm, right? So what we end up with are and this is way exaggerated here, but that is probably a more realistic idea of what that atmosphere around the Earth is, what that ocean of air around the Earth is. So we're going to leave that drawing like that. We're going to add to our notes here, though, real quick. So just like the ocean, we'll say it is not always calm. Right? The ocean isn't flat calm all the time. I'm going to put this right here. Some areas are thicker than others. And I'll help you visualize that here in a second. Think about this. At the bottom here, between these two waves, there is way less air above your head than there is here. Let's say if you're directly below one of these tall waves. Here, you're going to feel lower air pressure than we would feel here, where we would consider this the highest air pressure, right? Because there's more air above your head weighing down on you, there's more pressure. And that's essentially what's going on. Again, that's way exaggerated, that drawing there, but it's a good way to kind of think of it as this wavy ocean. The lower areas between the waves are areas of low pressure, and those peaks, those thicker parts of the atmosphere are high pressure. Remember, air is fluid. It flows a lot like water, and it's, thinking of it as an ocean is really not that abstract. So let's jump in. Let's think about high pressure. Let's describe it. High pressure is what we'll call a peak in the atmosphere. And around high pressure, air is rushing down toward the ground and spreading out. It always spins to the right. So air tends to flow clockwise around high pressure. As that air rushes towards the ground and kind of fans out away from the area of high pressure, it tends to spin to the right. And I'll show you that in a drawing here in a second. But we want to associate the weather. When I know we have high pressure coming, we're thinking about high pressure is known for clear blue skies. And we'll talk about why that is here in just a minute. So if the weatherman's saying tomorrow is going to be high pressure here in Maine, I know we're going to have bright sunny skies fewer clouds, and really low chance of rain or snow or anything on a high pressure day. So I want to do a couple little drawings here for you. First, let's draw kind of that same analogy, but here's our ground again, and we've got our exaggerated mound of air here. What's going to happen is, because nature is always in search of that equilibrium, right? If there's a mound of air there, the air, that mound is going to want to kind of sink down, and as it does, the air flows downward and toward the ground and then fans out away. So if we have downward flowing air, we're essentially not going to get precipitation because we're not taking that warm, moist air near the ground and cooling it off. We're doing the opposite, right? We're bringing it down towards the ground. So sinking air is not going to cause precipitation. If we make air rise, that's where we're going to get clouds and rain. So on a weather map, high pressure is always drawn with a blue H. So we'll draw with a big, heavy, thick blue H. And I want to draw it like this. The winds around a high pressure system, I kind of think of this almost reminds me of like a ninja star or something. The winds around a high pressure system are always flowing outward away from the center, and they're curving to the right. They're kind of curving clockwise to the right. Okay, so we can think of a high pressure system. On a map, we can predict wind direction based on air pressure and high and low pressure systems in an area, and that's a way we think about high pressure. Air flowing downward, but it's also going out away, and it's spinning to the right. Now let's think about low pressure here. Low pressure, let's see. Low pressure is going to be basically the exact opposite. I'm going to call it, we'll say it is a valley in the atmosphere. And in a low pressure system, air is rushing inward toward the center and upward, and it spins to the left, which is opposite of high pressure. So when I hear that there's low pressure coming, first of all, as a fisherman, on a low pressure day, cloudy, sometimes a little bit of rain, those are the days I tend to find the fish bite the best too. When I know it's high pressure, that can make fishing kind of tricky. But a low pressure day, or the pressure's dropping, that tends to spur the fish to bite a little better, because low pressure is known for clouds and precipitation, right? Any kind of water falling from the sky is precipitation. So let's draw this in the same way that we kind of drew our high pressure. If here's my ground, now we're talking about, one of these valleys in the atmosphere, and I may draw it even more exaggerated than that, kind of like that. If we have an area that's a valley in the atmosphere, what's going to happen is these areas over in here, which are higher pressure, are going to force air inward and upward to kind of fill in that valley. And that's what we've got going on with a low pressure system. Honestly, I might even draw it like this. I'm going to say, we've got air flowing just like this. This is a kind of a good way to draw it right here. There's our air rising, and anytime we've got that warm, moist air along the ground rising, it's going to cool off as it rises, and as it cools off, we're going to get condensation, and condensation is going to form clouds. And if we get enough condensation in those clouds, we're going to have precipitation, whether it be rain or snow or some other form, sleet, hail, something along those lines. So there's our low pressure kind of side view of what's going on in the atmosphere. But let's draw here. A low pressure system on the map is always drawn with a red L. A red L. And we're going to use the same exact shape, okay, that we did with our blue high pressure system. Kind of the same shape, except now the arrows are flipped. Now we've got air flowing inward toward the center of our low pressure system. Kind of cool stuff, right? So I can predict the wind direction in a given place based upon what the air pressure is around it. We can figure out what direction the wind is going to be flowing from. So there you have it. High pressure, we have air flowing down and out away from the system, low pressure, that valley in the atmosphere. We're going to have air rushing toward it and then rising. And that rising air is going to cause clouds and precipitation. So pause here and finish up your notes if you want. We're going to switch gears in a second, and we'll move on and we'll work on our assignment for today that you're going to go ahead and post. So our assignment is posted under today's topic in Google Classroom. It's I believe it's the weather map activity, I called it, and I have it saved in Notability as well over in here. Building a weather map activity. Hopefully you've got this opened up in Notability and you're ready to go. This is just us getting used to drawing these symbols on a map. We're going to mix in that warm and cold front stuff that we did last time as well. And we'll start to put together a weather map that looks an awful lot like those weather maps you're going to see on the news. So let's jump right in and do our high and low pressure systems first. So our directions tell us we need a high pressure system. So I'm going to use blue. I might make my line even a little heavier too. We're going to use blue. We want a high pressure system over Maine, Oklahoma, and Idaho. Here's Maine. Hopefully you can find Maine on the map. Some of these other states might be tricky for you, but we got to know where Maine is. There's Maine. Here is Oklahoma. High pressure over Oklahoma. And Idaho over here is going to have high pressure. Now remember, high pressure, we're going to have arrows going outward, away from the area of high pressure, and spinning to the right. So your map should, when you're all said and done with your high pressures, should look a little something like this. Right? Just like that. There's our areas of high pressure. All right, now, if we're going to draw our low pressure, we're going to use a red color now, and we'll go to a low pressure system over Georgia, which is right here. We've got low pressure over Georgia, Wisconsin, which is going to be right here, and New Mexico over in here. Okay, so we've got low pressure systems here, and now we're gonna take these same exact looking arrows, except now they're gonna be flowing inward. As we know, air around a low pressure system spins counterclockwise. It spins to the left, and the air is rushing inward toward that pressure system, like this. Okay, and here's what I mean by being able to tell what direction the wind is going to blow from. This is how the weatherman can predict that. Let's say you live let's say you live right here in Nevada. They're going to be able to say, all right, that wind today is going to come out of the northeast because there's a high pressure system up there in Idaho, and we know the way wind behaves. So just kind of a fun, interesting way that weather models can predict wind direction. I used to pay attention a lot to wind direction as a whale watch captain in the Gulf of Maine here on the ocean. Wind direction had a lot to do with whether or not we were going whale watching that day. If we had like an easterly or a southeasterly wind, any kind of strong southeasterly wind, that is not good off the coast of Maine. You get some huge waves because you've got a long way for that wave to build and get really big on those easterly and southeasterly wind days. But if I checked the weather and I saw that we had like northerly winds in Maine, we knew we were going to have nice calm seas that day because essentially there's not a lot of water for those waves to build up if the wind's coming from the shore. Now the further you get from shore, generally, the bigger the waves will get on that northerly wind day. But just another connection that I used to have to pay really close attention as a whale watch captain to wind direction. So finally, let's just add these warm and cold fronts onto our map here. We know a warm front is going to be drawn with red, and we already have red dialed up here. So they say they want a warm front that's running from Michigan to North Carolina. So here's Michigan here, and we want to go from Michigan to North Carolina. So we're going to draw a red line from Michigan to North Carolina, and I'm going to put, oops, I don't need triangles. I want a red line from Michigan to North Carolina, and I want to have my red half circles all along that line. Color those in. There's my nice warm front. And in this case, my warm front symbol would tell me that the warm air is here and it's moving this way, right? Because my half circles are pointing kind of northeast. I didn't specify what direction it's flowing, but there you have it. It's going to be flowing to the northeast. Now, finally, a cold front. We know we're going to draw in blue. And that cold front, they're asking us to draw a cold front that is running from California to North Dakota. So a pretty long one, maybe all the way up California to North Dakota. And in this case, we're going to use blue triangles, if you remember. Boom. And we want to color those in. And now we've got ourselves a cold front running all the way across the country from California to North Dakota. And that tells me that this is cold air here and it's moving this way, right? Those arrows point the direction that that cold air mass is moving. So when you're done, your map should look a little something like that. Make sure you go ahead and submit this assignment via Google Classroom. I appreciate you logging in and following along with me today. Keep up all the good work. As always, shoot me an email with any questions, concerns, anything you need. I'm here for you. We will get through